typical question 3. Read as follow. We have given question 3.1. What are we given there? A half section of a ship, which is as shown in figure 2. As shown there in figure what? In figure 2. The side is vertically to a depth of 1 meter below the water line, and the curve to the center line is form of a what? Of a parabolic arc, as you can see there. The axis, there we have the axis of the parabolic begins a horizontal line of 1 meter below the water level. Says determine the magnitude and the direction of the resultant hydrostatic force per meter length. Note the per meter length along the half section. Take a density of water as 1000. There we've given the was 1.25 kgs per cubic meter. All right, we've given here our structure. Everything that we've talked about is depicted there or is drawn. So we're supposed to have what? Determine the magnitude of hydrostatic force and its resultant direction. I mean like its direction there. Resultant direction. All right. If we have given the horizontal surface, we know we'll have the force there, the resultant that will be acting there. All right. Also have some horizontal one that will take place. We know them. Also there we'll have a horizontal and a vertical. So we have to find this component. We'll have H horizontal. There we have the vertical, the resultant that will be acting. We want that there. So we'll use what? We'll use our thing there. So per se, now here we have two, since it's a parabolic, if I cut there like this, we'll have two forms there, we'll have two shapes. Here our center there, you see we'll have our arc of the circle like this. From there until there, we'll have something like shape there, we'll have our rectangle. So we have two shapes there. We have this shape there. Also we have what? A rectangle like that. This is a rectangle, also have this shape there. So we have to find that shape there. We have to find the area of that shape. I can call this, it's up to me or it's up to you. I can call this shape here, I can call it A there. Maybe somewhere here I can say this is B. There is D like that. A, B, C. Maybe here I can say C. All right. A, B, or let me just call it there. A, B, C, D. Maybe I can rewrite that C. So I want this area actually. What is the area? The whole of this area. How can we find that area then? All right. To get that area, we'll have first to find this piece, the area of this sector. Also we add with this area of the rectangle on the top there. How it goes, if you find the area, will be the area of A, B, C, D, which simply equals to what? The area of the rectangle there on the top, the area of the rectangle there, base multiplied by height plus the area of this sector here that I've shading plus this area. We know this is calculated by is 2/3 multiply by x multiply also by our y. That is how you can obtain that. So B, what is our base there? The same is like x, there is 3. This portion like this, it's our base there, will be what? 3. Here it is, we have the 3. This will be 3 multiplied by the height. Remember that it's a rectangle, is this portion will be what? 1 for that portion, only that portion. I'm talking about this rectangle there, yeah, on the top, like this, like that. So we have only that piece there, will be what? 3. This is the same, it's like 3 multiplied by 1. So we'll have that 3 multiplied by 1 plus now we have to add obviously 2 over 3. What is x here? Is 9. So here we have our 3, will be, we have our 3 there, multiplied by y, which is 2.5. No, we have 3. Okay, that is not 2.5, is from here until there. We want only this piece from there, only focusing on this piece. All right, so we have 1. Simply say 2.5 subtract 1, we'll have 1.5. So we'll multiply by 1.5. all right, this will give us our area. Then we'll obtain the area. This will be 6 meters squared. Obviously is measured in what? In meters. This will be meter squared. We have now the area for the combine. For combine, we've combined now everything there. We've combined this also plus the rectangle. We've combined. So since we've combined, now we are good to go. We can find the vertical component and our horizontal component. So finding our horizontal component, you can say H. We know horizontal component is given by density multiplied by gravity multiplied by area. This is our y bar. The density there, we are given to take the density to be that. Here it's our density there. So substituting that density, 1205 multiplied by what? The gravity is 9.81. The area. All right, the area. What will be the area? That's my question when you're talking about the horizontal part. The area of a horizontal, remember when you're focusing on the horizontal, like the one that is acting there, which simply equals to what? The area of the horizontal component, right, will be y multiplied by what? By 1. By 1. If we multiply by what? By 1, because they said we should take the width as 1. Remember here, this one, we have some shape like that. We'll take it as 1 by 1. Multiply by what? By 1. All right. So our y, we've given y there. Our y is this guy here, 2.5. Here it's y. Okay, multiply by 2.5. 2.5 multiplied by what? By 1. All right. Also multiply by y bar. Y bar is equals to y divided by 2. So we have y divided by 2, that is y bar. So y is what? Is 2.5 divided by what? By 2. This will be y bar there. Punching this, we should obtain this component to be 3.1,423. Obviously I can say kilonewtons. So that is what we have obtained there. All right, so let's find now vertical component. You can say V. Obviously will be density multiplied by gravity, but now multiplied by what? By volume. The density we have seen that was 2 like that, multiplied by gravity 9.81. Now what is volume? The volume is given by what? It's supposed to be area multiplied by what? by the width, but we said it's width. The width we took, will take it as 1, similar to the horizontal, because you are not given. If we are not given the width, we take it as 1. But if we are given the width, we'll substitute it. All right, but the area now, the area, how can we find the area? The area is, we combine everything, like the volume, like we combine, it's a combination. Now when you're talking about that, it's supposed to be of the holes, since it's acting downwards, right? Is affecting, we focus on this hole. If I shade like everything there, the whole of this path, also there from where the water starts, all the shape from the top until the bottom, like this. All right, that is, it's our area there. So we've calculated it. It's a combination of the two. We've said it's 6. We got it to be what? To be 6 meters. So it will be 6 there. This will be 6 multiplied by 1. All right, simply just what? 6. So we'll multiply this by what? Our volume will be what? 6. Then we punch this, we'll have the volume there to be 60,332 kilonewton. Now let us get the resultant. Using Pythagoras, we'll have h squared plus v squared. All right, now the square root, go down, h squared, there is 31,423, obviously it's in kilonewton, do not forget, plus 332 squared. So our answer will be in kilonewton. Since you've substituted those things to be in kilonewton, we'll have 68,024 kilonewton. So now we want they said you should calculate even the direction. We know will be given by the direction. There will be theta is equals to tan arc there, arctan. Obviously we'll have that we'll have our vertical component divided by horizontal. So this will be arctan. Vertical, it was what? Vertical component, it was 60,332. Obviously that was in what? In kilonewton. Also this one, the other guy, was in kilonewton, which is 31,423. Then what will be the value of theta? Will be what? 62, something. 60. You take, let me punch that on my calculator. We have there 60,332 into 31,423. This is 62,488, like that. So thank you guys for watching. May you kindly subscribe to my YouTube channel if it's your first time watching my video. Just become part of the family. Click the notification bell so that you'll be notified whenever I post a new video. Feel free to comment and to share this to your fellow classmates. All the best.